What you're seeing here has finally been implemented into the main branch of my engine. The previous lighting video from like a year ago was just on some separate branch just to test what the raycasting system could do. And so like for what it was doing, which is it was casting to every nearby light source per pixel every frame, it performed decently well, but it was only at like 60 FPS, which I think is too low, especially on a 1060. Like 60 is fine if it's like an iGPU, but on a 1060, it should really be higher. So, anyways, this is my second attempt, I guess you could say, at making a performant light engine. Although this is much simpler. It's just a single raycast towards the sun, which at this point is over there somewhere. The sun is just set up here to be going in circles around the terrain. It never actually dips below the horizon or anything. So you'll just see the shadows kind of orbiting. So as you can see, the lighting is done per face, and this is entirely just because it performs better. You can get away with doing less work. And a secondary reason is I think it looks slightly better, but that is probably just coping because it performs better. As well as the shadows right now are either completely in shadow or completely out of shadow. That can be changed if I do just multiple raycasts per face, which could even be done with temporal accumulation to not to impact the frame rate, although it would impact the how dynamic the shadows are. So as a short little explanation of what the pipeline's doing is first I run a full screen shader to identify the visible faces and deduplicate them. And then immediately after that, I run a shader per face, which will take the previous frame's data and copy it over into the current frame, only if the face was visible in both frames. If it wasn't visible, I run some disocclusion shader to calculate that face's data. Um, and then after that, after I've calculated the data and brought over the temporal data, I just run another full screen shader to do the shading of each face. So as you can see, the shadows, of course, are per face, which means that the greedy meshing would have to change every frame if it was doing it per color. So instead, what you can do is just greedy mesh everything and then have some indirection to a per face buffer. So if I go and turn on the wireframe, it's kind of hard to see, but if I look at this big square right here, you can see that that's a ton of different colors. Oops, I just deleted the floor. And that's all meshed into a single face. And really that's necessary because the shadows are moving. So if I turn on the wireframe here, you can see none of the mesh is changing when the shadows move or anything. And it's actually very cheap, the voxel data lookup, because I can't store the type or the color information with the voxel data, sorry, with the mesh anymore. So what I can use is my temporal system on disocclusion for each face. I look up the type data from the volumetric data structure, which is the 64 tree. And then I just keep it in the temporal cache. And it's very, very cheap to look up that data in the temporal cache. It's practically free because I'm already using that system for the lighting. So I'm already making that trip to the memory. So that's actually been one optimization. I've made a few since the last video. And so if I go to this scene here, sorry, not that scene, this scene here, you can see the FPS is 370, but when I'm not recording, it sits around 2.5 milliseconds, a little bit below 2.5. In the previous video, it was also at 2.5 milliseconds. So I've gone from no shadows to sun shadows at the same frame time for this scene. If I go to a few scenes over, this one here, before without recording, it sits around like I'd say like 1.05 milliseconds. I don't remember exactly. In the previous video is 0.7. So unfortunately for scenes like this, where it's already very cheap, the overhead of the two full screen passes does cost around 0.3 milliseconds. Um, but I think since the FPS is already so high in those scenes, it doesn't really matter. Um, what matters is that the expensive scenes aren't any more expensive, just because I've made some optimizations to, for one, the greedy meshing optimization, so there's a lot less quads, and I also made some optimizations to the how the culling's done. So that's about it, I think. Next plans is right now I don't really have a very good top level acceleration structure, just because I've been holding off until I get around to sort of dynamic objects. So I think that's what I want to tackle next, is that there can be like entities and such that are moving around the scene and updating the data structure for the raycasting. So just before the end of the video, I'm just going to put an image on the screen to show what the performance is like on my UHD 630 graphics, which is my Intel integrated graphics. Yeah, I think that's it. Thanks for watching.